Yeah, hello everyone. So, good evening. Good evening to all of you. So, I think I am audible and visible to you. So, today is our week 7. So, to, today we will be solving some questions like last week. So, let me introduce myself. I am Shubhanu Haldar. I am a PhD student at IIT Delhi. So, I am a TA of this course. So, as we in this session we try to solve some questions, so we will be doing the same for this week also. So this week we will be try to see the dynamic programming basically. So in dynamic programming we try to solve by two approaches. One is bottom up and one is top down approach. Okay, so you also know that the bottom up approach, this is also called the this is also you have to form a table, and in top down you have to do something. So we'll see, like, for top down approach we uses the memoization technique, and for bottom up approach we use the tabulation technique. So in today's topic we will be solving some problem. Okay, and try to see how dynamic programming help us to solve such problems. Okay, so basically what is dynamic programming? So dynamic programming approach is to, if you have a very big problem, so what we do that, uh, sorry, so if you have a very big problem, so what we do that we break the problem into a simplest one. Okay, so okay, so one of the very popular dynamic programming problem is the longest common subsequence problem. Okay, so in this subsequence, so we are given two sequence, uh, that is x1 to xm and y1 to yn. Okay, so we wish to find a maximum length common subsequence of x and y, and following is the recursive formulation of the longest common subsequence problem. Okay, so you have to identify these, basically these a, b and c, what should be in the position in the algorithm. Okay, so as we have done the last few weeks, so please try to put your answer in the chat box, and we'll discuss this then. So just give me a second. Okay, so what is the example of longest common subsequence? Suppose if you take one example like a b c a b. Okay, and another example is s2. So this is one string, first string, and this is second string. Okay, uh, so you can say like a e c b. Okay, fine. Okay, so what you can do, you can see that what is the longest common subsequence. Okay, you can see that here you have acb, and here you also got acb. Okay, so the longest common subsequence here is acb. Fine. Okay, now the problem is how you will find it. Okay, so okay, so as we have discussed now that what is the top down approach, like, and the bottom up approach. So dynamic programming, so if you have a dynamic programming problem, so you can solve it in two ways. Okay, so one is top down approach and one is bottom up approach. Okay, so 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 this top down approach uses the memoization technique. Okay, memoization technique means it try to remember the steps you have already taken. Okay, so suppose memoization technique means like you have a graph like this. Okay, so from node 1 to 2 you have cost like 10, or from 1 to 3 you have cost 2, and here from 3. So you can see that from if you go this path, so if you want to reach 2, okay, and if you follow this path 1 to 3, then 3 to 2, then your cost is 5. Or if you follow this path 1 to 2, then your cost is 10. Okay, so which one is better? 5 is better. Okay, so memoization techniques basically try to remember the previous part. Okay, so this is the memoization technique, and this bottom up technique uses basically the tabulation approach. Okay, fine. So top down means you are solving the problem from top to down. Okay, and bottom up means you are solving the problem from, so if this is the table, so you are solving the problem from here to here. Okay, from 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 top to bottom. Okay, fine. So what is our goal now? So our goal is to find the find the what should be the longest common subsequence. We have to find the longest common subsequence, which is ACB. Okay, fine. So what can we do? So we will be using the technique of tabulation method. Okay, or the bottom up approach. So we'll do ABCAB. Okay. Fine. So what you will do, first you don't have any sequence, so you will be writing 0. Fine. Then what we will do, that if you see that from A to A there is a matching, let's say right A. Okay, from, so this is S2 and this is S1. Okay, fine. So what this say thing, that if m is equal to 0 or n is equal to 0, write 0. Okay, fine. So if xm is equal to yn, so the thing is, if xm is equal to yn, if we get a match, we are getting a match here. Okay, xm is equal to yn, then what do? That you will be recursively calling the same function. Okay, fine. So what we'll do, so now in this case xm is equal to ym. Okay, so you put 1 plus LCS m minus 1 n minus 1. So you will be doing 1 plus like 0 from here. Okay, 1 plus LCM m minus 1 n minus 1. And if xm not is equal to yn, so if a and b are not similar, this a and this b is not similar, so what we will do, okay, xm not is equal to yn. If this is the case, then what we will do, we will be trying to find the maximum of LCS which coordinate basically. So you will be trying to find the maximum of, for this you will be trying to find the maximum of this coordinate and this coordinate. For this, what we will do, m, this is what, LCS m comma n minus 1 and LCS m minus 1 comma n, I think so. Okay, that is, so this is basically m and this is basically n. Fine, this is m, this is n. Okay, so what we'll do, m means row, this means column. Okay, row and column. Fine, so m and n minus 1, so this means this is n minus 1 and this is m. So for this, what we will do, so this is your mn. If this is your mn, what is m minus 1 and n minus 1? Okay, so this is m comma n minus 1 and this is m minus 1 comma n. Fine, are you getting it? So from these two you will be finding the maximum one. Okay, so here you will be solving the maximum one. Okay, so what we will do, so if you do this, you can see that you can check that what should be the output here. So your output will be so let me clear that. Now see, this C is common. Okay, so what we will do, we will do maximum of these two things. Okay, so what is the maximum of 2? Like, see, no, this C is common, so xm is equal to ym. Okay, so what we will do, 1 plus LCS m minus 1 n minus 1, so 1 plus this thing. Got it? Okay, plus 1. Okay, so this was your formula. So A and C is not common, so you will be writing the maximum of these two. So that's why 2. Same B and C is not common, maximum of these two. A and B is not common, so that's why 1. Okay, B and B is common, so you will be writing 1 plus this one. Okay, now so these two are common, so C and B is not common, so you will be writing any one. Okay, 2, and if B and B is common, so you will be writing 2 plus 1 3. Got it? So 3 is your final answer. Okay, this 3 is your final answer. Okay, so how will you go back to find the solution of your question? So what is, if anyone asks you, so what should be the what is the longest subsequence? So first you have reached here, so 3, so this is B, you are fine. So you have to just find out where you have increased the value. So you can see here that here you have increased the value, so which is C, and here you have increased the value, which is A. So your longest common subsequence is ACB. Got it? So basically you have to check where you have increased the value from this, from your diagonal. Okay, so you have to check the position. So here, like C, B, A. Got it? A, C, B. Fine. So you can see here the answer also, like xm is equal to y and n. Fine. So now the second question is, given the sequence. Okay, so in first question we have seen the formula or the algorithm for the longest common subsequence. Okay, in the second question we will be trying to solve the longest common subsequence using this tabulation method. So if these two are given to string, so which of the following is true? So BCA is the longest common subsequence of x and y. This is one of the longest common subsequence of x and y. LCS of length 5 or more exists, or none of these. So we have to solve the question. So what is the best possible way to solve the question? So what we can do? So we can use a we can use a table. Okay, so make a table here. Okay, so this is how you have to solve the question. Okay, so what is your S1? S1 is equal to A B C B D A B, A B C B D A B. Fine, fine. What is your S2? S2 is equal to B D C A B A. Fine. So you will do one row. You will okay. Fine. Now what you will do? You will write A B C B D A B. Fine. B D C A B A. Fine. So how we'll do it? So first you will be writing 0 here. Okay, 0, all zeros in first row and first column. Fine. Now we'll see that AB is similar or not. So if what you have seen, M is equal to 0 or N is equal to 0, write 0. Fine. You are done. Fine. So see this algorithm carefully. Okay. So what we have found out that this A is if x m is equal to y n, then what we will do? So this will be m n minus 1 and m minus 1 n. Fine. So if two are equal, then 1 plus the diagonal element, or otherwise write the maximum one. Okay. So if b and a equal, no. So you have to write the maximum, this one. bb equal, so you have to 1 plus this one. Fine. Now BC equal, no. So you have to, if these two are not equal, then what you have to do? You have to write the maximum one. BB equal, fine. So you have to write from here diagonal element 1 only. DB equal, no, 1. AB equal, no, 1. BB equal, yes, but you have to write from here only. Okay, got it? Now what you will do? Now DA equal, no. Now BD equal, no. So you have to write the maximum between 1 and 0. So 1. Okay. Now CD equal, yes, no. So 1. Okay. Now BD equal, no. So 1. Now DD equal, yes. So you will be writing 2 here. Okay. So AD equal, no. So 2. BD equal, no, 2. Okay. Now CAC equal, no, 0. Now BC equal, no. Write 1. Maximum of this. Okay. Now CC equal, yes. So maximum of this 2. Okay. Now BC equal, no. So maximum 2. Now DC equal, no. So maximum 2. Now AC equal, no. Maximum 2. Now BC equal, no. Maximum 2. Fine. So for AA equal, yes. AA equal, so maximum 1. Okay. Now AB equal, no. 1. So AC equal, no. Maximum 2. BA equal, no. So maximum 2. Now DA equal, no. Maximum 2. So AA equal, yes. So diagonal, add 1 with the diagonal element. Okay. Now BB equal, BA equal, yes, no. So maximum 1. So 0 so AB equal, no. AB equal, no. So what we will do? So we'll write the maximum one. Aja. BB, so BB equal, so you will be adding diagonal element. Okay. Now CB equal, no. So maximum element. So BB equal, so you will be right. So okay. Now DB. Okay. Now AB. Okay. BB 4. Fine. Now what you will do? AA. So 0 1. Okay. Now BB, yes. So you will be 2. Now CA, no. BA, no. Now DA, no. Now AA is 4, and this is BB 4. Okay. So 4 is the maximum element. Okay. So where what should be the maximum common subsequent? You can see here you change the value first. Okay, then you change the value, then you, so you change the value here, so this is 4. Okay, so from where this 4 come from, so this 4 come from here. Okay, so and this 4 also come from here, so and then this 4 came from here. Okay, then from where this 4 came from, so this 4 came from here, then this 4 came from here and here. Okay, so what should be the what should be your maximum common subsequent? So this will be that b b a d b, fine, b d a b. Okay, so you can see that BCBA is a option. We have to check that BCBA can be a sequence. So if we start from here, so this is B. Okay, so B, so you are starting from here B. Okay, now for C where you have to go, so this 4 comes from here, so BA. Okay, so you can see that option B is BDAB, which we wrote then only, BDAB and BCBA. Okay, BCBA. Okay, this B. Okay, this C, fine, then you came here, so this B. Okay, BCB, ABCD. So this is A, this A. Okay, then A, B, C, sorry, so this is basically B, C, B, A. So where from BCBA coming from? So BCBA coming from here, because here you change the value from the diagonal BC. So this is A, then you change the value here, which is from here. Here. So from where these 3 came from? So these 3 came from here. Okay, so these 3. So B, so A is done. How you found out that how A is coming from here. Now B is coming from here. Okay, now C is coming from here. Okay, C and B is coming from here. Okay, so BC, AB and BD, AB is your 2 solution. So your correct option is this one. So BCBA is one of the LCS of XY. Okay, so you can remember that for the tabulation method, so more than one solution is possible. Okay, fine. So now this is the next question. So what is the value stored in AR22 when the following code is executed? So try to see that what the code is actually doing. So this is a code for C++. So hash impress .h, you are adding the header files, and this is a get min function. So what does it do? So this finding the minimum, okay, between 2 elements, integer A and integer B. If you give a input, then it finds that what is the minimum element. Okay, then this is a code for edit distance. So you know what is edit distance function to do, and this is the main function. So you have ABCD and DEFG. Okay, so you have to find the edit distance. So what should be the what should be your output after you run this edit distance function. Okay, so you have ABCD, so you have ABCD and DEFG. Okay, so ABCD and DEFG. Okay, so you have this, you have these two word. Okay, so edit distance means, so you can do replace, remove, or insert. Okay, so so if you do replace, remove, or insert, so what should be the case, like what is the minimum number of operation you needed. Okay, so follow this too. So try to understand that what this edit distance function do basically. Okay, so it tells us if r not is equal to c. Okay, like this is row not is equal to column. So you will solve this by tabulation method. Fine. So this is telling that you will solve this by tabulation method. Okay, so this is saying that, okay, so I am taking another example, like a big example. Okay, so like, so this is for null string. Okay, now A, B, C, D and D, E, F, G. Fine. Fine. So what we will do, so what this function does basically, if r not is equal to c. Okay, so what you do, so if we zoom out our rows and columns, let's see here. So in edit distance you have these three operations. Okay, so what you will do, in this column you will do 1 plus minimum of these three operation: replace, remove, or insert. Okay, so 1 plus minimum of these three operation. Got it? Okay, so if r is equal to c, then you will do this. Okay, fine. If r not this is r not is equal to c, so if r is equal to c, then what you will do, you just copy the diagonal element. You just copy it here. Okay, so this is the operation this code is saying. See, if si minus 1 is equal to s to j minus 1, si minus 1 means so this is s1. Okay, and this is it, s2. Okay, so this is saying this, if si minus 1, where this is this I or j has reached, maybe I is here, j is here. Fine. Okay, so I minus 1 is equal to j minus 1 if arr I minus 1 j minus 1 less than minimum. Okay, so arr means this one, the arr means this table they are talking about. Okay, minimum is equal to arr I minus 1 j minus 1. Okay, so minimum is equal to minimum of, you just copy it. Okay, and otherwise you just you do 1 plus arr I minus 1 j minus 1. Okay, fine. So how we'll do it, we'll do it here. Okay, so a null. So basically what we will do, 1 2 3 4, because from null string you want to change a, so you have to insert a. you have to insert B, insert C, and insert D. So these are 4 operation. Okay, so that's why C 1 2 3 4. Fine. Okay, now so if you want to change A to D, what operation you need? Okay, so if R not is, you can see here, if R not is equal to C, you just do 1 plus minimum of the thing. Okay, so you will do 1 plus, what is the minimum? 0. So 1 plus minimum means 1, 0 plus 0 is the minimum one, so this is the minimum one. Okay, now 0 plus 1 means 1. Now if these are not same, so minimum 1, 1 plus 2. So CD is not same, so minimum, so 2 plus 1 3. So this is not minimum, so D. Okay, now these D and D are same, so what you will do, you will just copy the diagonal element. Okay, so you can see here, so that is 3. Fine. A E not same, 2. B E not same, so 1 is minimum, 1 plus 1 2. C E not same, so 2 is minimum, 2 plus 2 3. Now D E not same, so 3 plus 1 4. Fine. Now AF, so AF is not same. Okay, so 2 plus 1 3. Now BF is not same, so 2 plus 1 3. Now CF is not same, so 2 plus 1 3. Now DF is not same, 3 plus 1 4. Now AG is not same, so 3 plus 1 4, 3 plus 1 4, 3 plus 1 4, and 3 plus 1 4. Fine. So this is the thing. So so minimum 4 operation you need here. Okay, you can see here also. So okay. So ARR 2 2. So what is the value in ARR 2 2? So this is 0 1 2, 0 1 2. So this is ARR 2 2. So our question is basically you have to find which is the value of ARR 2 2, which is 2. Sorry. Okay. So this is the ARR. Fine. So this is the ARR function. Got it? You got the idea of longest common subsequence and the edit distance function, I think. So this is the longest common subsequence and edit distance function. Okay. Now try to solve this question. So this is a traveling salesman problem. So what is the cost to travel from node A to node C? Try to find the answer and write it in chat box. Okay, so try to find out the answer. Okay, so so this is a directed graph. So this is a directed graph and which is also weighted. Okay, so this is a weighted directed graph. So now the thing is that you have to find the what you have to do. So you have to consider the following graph and what is the minimum cost to travel from node A to node C. Okay, so you can see that the minimum cost to travel from so how can you find it? So from A to D, which is 1. Okay, now D to B, which is -2, and B to C, which is 3. Okay, so you have to find from source destination. So this is the path, but how should you find this? So this is 2. So this is very intuitive from the picture that you can find it, or otherwise what you have to do, that you have to find the all pair shortest path. Okay, okay, so if you do all pair shortest path, so all pair shortest path mean you have to write the Floyd-Warshall algorithm. Okay, okay, so what is, so this is very intuitive that you can find here to here and then here. So otherwise if you want to find using the algorithm, how algorithm will find it, so you have to use the Floyd-Warshall algorithm. Okay, node A to node F. So this is the source and this is the destination. Source and destination. Okay, source and destination. So what is the minimum cost to travel from node A to node F? Yes, Joy, you are very right. So answer is 4, of course. But how will you do it? So this is the question. Like, can you show the Floyd-Warshall algorithm at all?
Sorry, I don't have idea.
Yeah. So I am telling that. Using the Floyd-Warshall algorithm, like, do you know that how to show how to find this using the Floyd-Warshall algorithm? So do you know the steps and all? So otherwise I can show you.
Sorry, I don't know the
Okay,
steps
okay,
of
okay, no problem, no
Varsha.
problem. I'll explain. So let us take this space, okay. So and let us first draw a graph, okay. So we don't have, I didn't dedicated any space for this, so let's try here only, okay. So suppose you have a graph like this, okay. Suppose 1, so 2, then 3, then 4. So this is your graph. So this may be a directed graph, okay. Where did it go? Okay, so this one. So this is a directed graph, okay. So and this is also weighted, okay. So maybe this weight is 9, this weight is 4, so this weight is 1. Join this, so this weight is 2, okay. Assume these are the weights, I missed it, this weight is 8, okay. And so you have to find all pair shortest distance. So all pair shortest distance means, so you have to find, so this is the source and every node can be a destination, okay. Okay, fine. So previously what you did that so each node can be a source, it can be a source and other can be a destination, okay. Also what happened that any node can be a source and any node can be a destination, okay. So this is the concept of all pair shortest path. So previously we found out that Dicastra and Bellman-Ford algorithm. So we use the Bellman-Ford algorithm using the order of VE, okay. So this is for single source shortest path, but here we have previously for Bellman-Ford was single source, okay. Now we have multiple source, okay. Any node can be a source, so that's why we are using Lloyd Warshall, okay. So this is very intuitive that if single source take VE time, then multiple source or all, if where each node can be a source, it will take V into VE, okay. That's why that is V square E, fine. So we are trying to find a algorithm where this time taken is much less than V square E, okay. So this is our goal, okay. So now what we'll do, so we will be using this Floyd-Warshall algorithm. So how we do this, that is, first take d0. D0 means the known distance, the distance we know at this point basically. So we have to 4 nodes, 1 2 3 4, 2 3 4. So from 1 to 1 distance is 0, 0 to 0 distance is 0, 3 to 3 distance 0 0, no problem. Now from 1 to 2 you can go from 8, distance 8, fine. Now from 1 to 3 you can't go to 1 to 3 directly. From 1 you cannot go to 1 to 3 directly. So that's why distance is infinity. Now from 1 to 4 distance is 2, fine. 1 to 4 distance is okay, so this is 1, okay. So this is 1 to 4 distance is 1, fine, okay. Now so this is infinity and this is 1, fine. Now like this, if you follow, so this is 1 to 2, 2 to 1 infinity, 2 to 2 0, 2 to 3 this is 1, okay, and 2 to 4 this is infinity, okay. So you can see that 2 to 1, 2 to from 2 to 3, 2 to 3 this is 1, fine. So you fill up like this for infinity 0 infinity 2 9 0, fine. there is no problem. Okay, now what we will do now, so here you have seen that in this example, when you are solving this example, you have seen that so your source was this one A, and your destination was this one D. Okay, so source and this was destination, fine. So so you could have go to this way, you could have go to take this way. Okay, fine. So why you have chosen that way only? Okay, so you could have go to this way. So this was shortest. Okay, so now if you in if we include node number 1, so what could happen? Okay, so this means that this graph indicate that you are including node number D. Okay, so here, so that's why we will try to explore. If we include node number 1, if we go via node number 1, are we getting any better path? So this is our goal basically. Okay, so d1 is equal to 1 2 3 4, 1 2 3 4. Okay, fine. So this is 0, so 0, so from 1 to we will not have any change. Okay, so from 2 to 1, so if you go from 2 to 1, so there is no direct route via 1, so this is also infinity. Okay. So you have to follow the graph and fill the this one. So please try to fill this one.
Uh, Shubhanu, you are on mute. I can't hear.
Oh, sorry. So this is from 3 to 1. So if you see here, from 3 to 1 you can go to 4. Okay, fine. So now 3 to 2, so this line basically. So from 3 to 2, previously we had this one. Previously we had 3 to 2, we had infinity. Okay, we can't go directly from 3 to 2. Okay, so this way we can go. Okay, so now if we go via 1, so we have a root now. 4 plus 8, this is 12. So infinity is greater than 12, so 12 is basically less than infinity. So we are updating this. Same for here, same for 3 to 4. For 3 to 4, for 3 to 4 we can, there is not any direct way. So previously it was infinity, but now we can go via 1. So if we go via 1, so this is 4 plus 8. Oh, 4, sorry, so 4 plus 1, that is 5. Okay, so this was 1. So that's why I have updated this. Okay, got it? How we are updating? So basically 3 to 4 there was no direct route. So what we did, we go to 3 to 1 and then 1 to 4. Okay, so this is the operation we have done. Okay, So what our dynamic programming
Okay.
will help here, like what Floyd Warshall does, basically it tries to memorize the thing that okay, from 3 to 1 we have a route with this minimum distance, from 1 to 4 we also have a route with this distance. Okay, so this is how Floyd Warshall help us. Okay, so if we complete the table, so this becomes infinity. So 4 to 1, 4 to 1, 4 to 1, infinity. Okay, 290, otherwise so 290. So we don't have any change here. So 290. If we go from 1, if we take path via 1, we don't get any change here. Okay, now what if we take d2? D2 means if we take if we take path via 2, if we take path via node 2. Okay, so let's see what change. uh, 08 is fine. Now from 1 to 3. Okay, from 1 to 3. So from 1 to 3, if I go via 2, so you take it takes 9, but previously it was infinity. Okay, so we'll update this as. Now what we'll do, like otherwise infinity 0 1 infinity 4 12 0 5 infinity 2. Now 4 to 3. If you want to go from 4 to 3, node 4 to node 3, you previously you use distance 9. Now if you take route 2, take route via 2, so you need 2 plus 1 3. Okay, so this will be updated. So previously it was 9. Okay, box means the previous thing. Now it is updated as 3. So these two value are updated in this iteration. What it? So now for the 3, zero one six. Okay, 4 12 0 5. So from 4 to 1, you can see that 4 to 1 we have a better route using 3. So 9 and 4. So it is 9 and 4, or okay, 9. Oh, 3, 4 12 0 5. Fine. 4 to 1, 4 to 1. How can I go using 3? So this is 9 and 4. Okay, so this is 1 to 4. So 1 to 4 plus 1. 4 to 1. 4 to 1 is so the value changed here. So that is this 5, this 6, and this 13. Okay, so 4 to 1 via 3. 4 to 1 via 3, it took me 13. Okay. this is the distance 4. Like if you take the node 4, so this will be the operation. Okay, fine. So this is how Floyd Warshall works basically. Okay, so now if this is the given graph, so what is the minimum cost to travel from vertex 1 to 3? So you can see that this cost is 8, so you have to find the other distances. Is minus 3 is the correct answer, and this 1 to 5, the root is basically 1 to 5, 5 to 4, and then this one. Now this is a very fundamental question about the Dijkstra and Bellman flow.
Only S2 is.
So the first one is telling that Dijkstra is not affected by the negative edge weight cycle in the graph and gives correct shortest path. So we have seen that
That's it.
no, only
That's the
S2.
false.
No. So
Am I right?
basically Dijkstra cannot find the negative edge cycle. So that's why we came with the Bellman-Ford algorithm, so that we can run the loop, run the loop for the number of times. If the graph has n number of nodes, then we will run the loop for n plus 1 times. Okay. So this is the Bellman-Ford. This was the Bellman-Ford algorithm, and Bellman-Ford algorithm finds all negative edge weight cycle present in the graph. Okay, so Bellman-Ford algorithm cannot find all the negative edge cycle. Okay, so Bellman-Ford algorithm basically detects existence of negative cycle, but it doesn't name the nodes in the cycle explicitly. Okay, so it find the negative weight cycle, but it will tell yes or no answer, but cannot identify where the negative weight cycle is actually present. Okay, so also Bellman-Ford Algorithm finds the shortest path even if there is a negative edge weight but not in there is a negative weight cycle. So this is a question about the matrix chain multiplication. বলছি তুমি এখনই খেতে যাচ্ছ? হ্যাঁ, যাও যাও আজকে তো সেই খাবার আছে তো, যাও যাও সেই খাবার আছে আজকে, যাও যাও। So so we have to solve we have to find out the minimum number of matrix chain minimum number of multiplication required to multiply the following three matrices. So here you can see that you have three matrices A, B, C. So you can multiply it using two ways. A, B, and A, B, C. Okay. So A, B is basically 3 by 7. Okay. B, C is 7 by 2. And C is 2 by 9. Fine. And here also 3 by 7, 7 by 2, 2 by 9. So if you first multiply these two, so how? So okay. So for this, how many multiplication you need? You need 3 into 7 into 2, which is 42 multiplication. Fine. Now if you then you do multiply with C, then how many multiplication you require? That is 3 into 2 into 9, because this will become 3 into 2 matrix. Okay, so it will be 6 9s are 54 multiplication. Okay, and सर ये वाला लाइट भी जला दो, ये वाला नीचे नीचे है. So total how many multiplication you need? So you need is 54 plus 42, that is 96 multiplication. Okay, now if you do this way, okay, so how many multiplication you need? 7 to the 14, 14 9s are 126 multiplication. Okay, so then it will become 7 by 9 matrix. Then how many multiplication you do? 3 cross 7 into 9, what is 189? So you need 189 plus 126, which is 315 multiplication. So see the differences where one in one place you need 96 multiplication, in another place you need 315 multiplication. Okay, so minimum number of multiplication required here is 96. Now this is also a problem of longest common subsequence. So QP, QRR, and these two string is given. Let x be the length of the longest common subsequence, not necessarily the contiguous. So between A and B, let y be the number of such longest common subsequence between A and B. Then x plus 10y. Okay. So what is x and what is y? So x be the length of the longest common subsequence and y represent the number of such longest common subsequence exists. Okay. So please try to solve it by yourself. Like we have already discussed the method here. So this one. So the very first question we discussed. So this is the algorithm for longest common subsequence. Okay. So if you don't remember it, please take a picture of it or write it down, the algorithm. So I have explained it how to find it. So how to find the longest common subsequence and what will be the number. Okay. Okay, so here x is equal to 3. 3 is basically the length of longest common subsequence. Okay, and y is equal to 1 because only one subsequence you can get here. Also in this question you can see here length is basically 4 and only 2 subsequence you can get. Okay, fine. So this is the algorithm and you have to find the answer for this two string. Okay. Please try to solve it by yourself and then I'll show you the answer. I hope you have tried to solve this using the tabulation method. Okay, so this is what you will get if you solve using the tabulation method. Okay, so how many possible subsequences you will get? What is the uh, number of longest common subsequence? That is 4. Okay, so this is fine. So x is 4, that is fixed. Now how many you can get? Okay, so this is the answer. So so you have to you will check from here, so you have to check from bottom up approach. Okay, so you can get from here, r you can get. Okay, so from here this 4 is not changing, so this is coming, this 4 is coming from here, so this 4 is basically representing r, so that's why we have written r everywhere. Okay, now what happened now, so this 4, from where this 4 is coming from, so this 4 is coming from here. Okay, this 3, so this 3 means q and r. Okay, but this 3, where this 3 is changing, so this 3 is changing from here, like 3 or 3, so here you have two paths. Okay, you can go up or you can go left. Okay, now from where this 3 is changing and where this 3 is changing. Okay, so this 3 is changing, so this is q q. Okay, so q q, and this 3 is changing from r r r. Okay, so that's why r r. Okay, fine, two possible situation is fine. Okay, now so from where this 2 is coming from, so from where this 2 is coming from, this is coming from this p. Okay, so this p. Okay, so that's why you see here p. Now another is you can come from p, also you can come from q. Okay, that's why fine. Now where this 2 is coming from, this 2 is coming from this 1, so this 1 means q q q, q. Okay, now p. Okay, so there are, so these two are same basically, so these two are same. Okay, so x is equal to 4 and y is equal to 3, so the answer is 34. Fine. Now the question is, in the given graph, how many intermediate vertices are required to travel from node A to node E at a minimum cost. So node A is your source. Okay, and what is your destination? Node E is your destination. Okay, so how many intermediate vertices are required? Okay, so you have to find the number of intermediate vertices. Let's check the answer. So from source to destination, so you can go via a to b. Okay, then you can go via B to C, then C to E. So which will be 5 plus 3 minus 7, which is 1. Okay, so C is the correct answer. So how are you getting B? So how are you getting 0? If you can write it in the chat box. So it is number of intermediate vertices, that is B and C. Okay, so this will be the option correct answer. Yeah. So now the question is, what approach is being followed by Floyd-Warshall algorithm? जा रहे हो?
आप इवेंट बेस्ड मॉडल ना मैंने भेज दिया उनको।
मेल कर दिए?
आप वो ना इसका लाइव डेटा सेट के जो प्रॉब्लम्स है उनका मेल कर दो,
ठीक है।
कल सुबह देख लेते हैं।
ठीक है, बाय।
एंड फिर क्या रह जाएगा हमारे पास, लाइव डेटा पे काम करना था बेसिकली।
ओके ओके। आज सर के साथ मीटिंग हुआ होगा उसका, सर भी कुछ अपडेट देंगे रात को।
ओके,
ठीक है, फिर मैं बताता हूँ कल।
लेट तो नहीं चल रहा ना टाइम नहीं?
ना ना, सही है।
Shubhan, you are on mute.
Okay, okay, sorry. So next question is, a graph G is such that every vertex is connected to every other vertex via direct link. We need to find the shortest path between two vertices using Bellman-Ford algorithm. How much time does it takes? So basically, you have a given graph G. So here we are talking about the time complexity and all. Okay, so you are given graph G such that every vertex is connected to other vertex via direct link basically. Okay, so here all are connected. Okay, so we need to find the shortest path between two vertices using Bellman-Ford. Okay, so for Bellman-Ford, how much time we need? So in Bellman-Ford algorithm, for every round of edges, we so we know that in Bellman-Ford we relax the edges. Okay, so how much time we relax the edge? We relax the edges number of times there is number of edge. Okay, each edge relaxation takes constant time. Okay, in generals there are v minus 1 rounds excluding the verification round. Okay, means the last round. So in Bellman-Ford we know the verification round means the last round we take one extra round to check there is a negative weight cycle or not. Okay, so you can see here that for total time is v minus 1 into order of e into order of 1. So order of 1 is basically the constant time for relaxation. So this is the time for relaxation, and this is we are doing for each edge. Okay, and in general there are v minus 1 rounds. Okay, fine. So that's why order of v. Okay, so for complete graph that is v square, and total time is v cube. So fine. So complete graph means, so this is the option v cube. So this is a complete graph, so each node is connected to everyone. Okay, the next question is, when a top down approach of dynamic programming is applied to a problem, it usually decreases what? Okay, so uh, so if there is a top down approach of dynamic programming, so this decreases the time complexity and increases the space complexity, because for top down approach and bottom up approach you both have to use the tabulation method or memoization method. Okay, so in memoization method also you use some recursive function and all, so that's why you ended up with creating more space in the RAM. So it decreases the time complexity but increases the space complexity. Fine. Now we have a question. So please read this question carefully, and there are multiple questions related to this paragraph. Okay, so reading is a very important part of this question. So you are playing an old style video game in which you have to shoot down alien spaceship as they fly across the screen from left to right. Okay, so you have a video game, like you have a TV, so there are some aliens. Okay, so it fly across the TV. Okay, so the aliens mean, you can think about the bird. Okay, so from left to right. Okay, so from left to right it goes. Okay, okay, so it basically goes like this. Fine. Now what you are doing, so in which you have to shoot down alien spaceship as they fly across the screen from left to right. Each spaceship flies across the screen at a specified height. Okay, so each spaceship, okay, this is the spaceship, flies across the screen at a specified height. Okay, you have an anti-aircraft gun set to the shoot down all spaceship at a certain height. Okay, spaceships fly one at a time. So if your gun is set to fire at the correct height, it will shoot down the spaceship currently trying to fly across the screen. Okay, so only one time one spaceship will be there, it will have certain distance, certain height. Okay, so one time it will have one alien, and it will have certain height. Okay, so if you are pointing to this height, okay, So then your alien will be uh, shot down. Okay, now you can set the initial height at which the gun fires. As the game progress you can reset the height, but only to a lower value. Okay, so first what you have to do, you can set a initial height at which the gun fires. Okay, so this is the height from 0 to 100. Okay, so first you can set it. So as the game progress you can just reset the height, but only to a lower value. So if you are pointing to 99, so you can go to 98, 97, 96. You cannot go to 100. Okay, so you are given in advance the height at which each spaceship flies. Okay, there are n spaceship numbered 1 to n in order in which they fly across the screen for 1 less than is equal to I less than is equal to n. Hi denote the height at which spaceship I flies. Fine. So you have given it already. So let Vi denote the maximum number of spaceship, from I to n that you can shot down with a single gun. Assuming start by shooting Vi, which of the following is valid? Recursive formulation of Vi. So note that the maximum of a empty set is defined to be 0. Okay. So please read the question first. So we know that one is longest common subsequence, one is longest increasing subsequence, and another is longest decreasing descending subsequence. Okay. So try to find a simple example of longest descending decreasing subsequence. Okay, I'll tell you like so this is a question from your assignment of last year. Okay, so try to solve this. Okay, so what is the longest descending subsequence? So suppose you have a number like 28, 12, 16, 10, 9, 8, 18, 7. Okay, so why this problem is a longest descending subsequence problem? First we have to understand that. Okay, so if you see that, focus on the line where uh, the it is said that the camera is not on. Okay, so it is said that you can set the initial height at which the gun fires. Okay, so you can set the initial height. Okay, now as the game progress, and also you know in advance, you are given in advance the height at which each spaceship flies. Okay, so you are given in advance at which each spaceship flies. So this is basically Hi. Okay, which is denoted by Hi. So there are n spaceship number 1 to n. So here it is number 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 spaceship. 9 spaceship we will fly from first one will fly from height 20, second one will try from height 8. So like you have a TV, okay, so this is your TV, okay. So I hope this was my favorite game one time. Oh, whatever. So this by that time I didn't understood how this happens. So this is your TP, okay, fine. So first what will happen, that one alien will come, okay. So one alien will come at height 20, okay. So this is height 20, okay. So this alien will come, and go height 20, fine, okay. In second time what will do, what will happen in second time, so this is height 8. At height 8 one alien will come and start from here, and it will go till here, okay, fine. Now third time what will happen, third time this 12, at 12 one alien will come, okay. So this will go from left to right, so this is left and this is right, fine. So in fourth time what will happen, this 16, so one will come, one alien will come and go right. Then what will happen, so this was 16, now here 10 will come, okay. So you know beforehand all the heights, okay. So how will you set, so what is the, so this is your gun, okay. So this is your gun, okay. So you can you cannot go up, okay. Your gun just go down, okay. So you first you set it at an initial position, okay. You set it at an initial position. So maybe so beforehand you know the weights, okay. So you know that at position 20, okay, first alien will come, okay. So your gun is pointing at this position, okay. Now the question is, then your second alien is coming at height 8. So if you go down and try to hit the alien at height 8, you never can go up, okay. Got the question, okay. So this is the scenario here. So what is the possible solution? So you have to see that what a maximum you can do. Let's see. So there are some subsequences possible. So one subsequence is, so first you kill 20, okay. Then you kill 8, okay. Then 8, then all are above 8, all these are above 8. Then you have only one option left, that is 7, okay. Then you kill 7. So what you have, so 20, 8, 7, fine, no problem, okay. Got it? This is a very interesting problem, okay. So now what will happen, now 20, fine. So you know that after 20 12 will come. So you hit 12, okay. Now so if 12 is coming, then you go 10, because you can't go to 16, because 16 is above 12. Then you have to go 7. So what will you get, 20, 12, 10, 9, 7. Got it? So this is the problem, okay. Now what can be the situation, now 20 you can go to 16 directly, 20, 16, then 10, then 9, then 7, fine. Now else what I can do, 20, 18, 7, okay. Also 8, 7. रिद्धू एक बार आओ, कितना दिन हो गया तुमको नहीं देखा। रिद्धू कितना दूर से लैब में गए थे लैब में देखा नहीं फिर हम थोड़ी देर बाद बात करते हैं मैं एक क्लास ले लेता हूँ ठीक है फिर हम खेलेंगे okay so this is basically the longest descending subsequence okay so we know that what is the formula for longest common subsequence so this will be the formula for longest descending subsequence so if so the so if vn is equal to 1 then so this is the option so if vn is equal to 1 okay so what is vn so vn is basically assuming you start by shooting vi okay so vi means so you start from 1 okay 1 plus maximum vi by j greater than if when j greater than I and h greater than j okay so this is nothing but the formula for the longest descending subsequence okay now the question is what is the size of the memo table of this problem so you know that in longest common subsequence what we do that we try to construct a table with each entry okay yeah, like s1 and s2 okay so we have to do one entry per spaceship so there are n spaceship so we have n memo table okay so in memoization table we have n entry okay so then it is saying that what is good order to compute the values of vi using dynamic programming okay so I think this is clear like this one so here you have to focus more that how the problem is here like you try to read the question again and again and then try to see this one like how we are solving the answer छोटा सा ही
क्या हो रहा है क्या प्रॉब्लम देके चले गए हो क्या? तलाक हो गया है सुबह 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 तो मैं यही करता हूँ।
तो यही करते हो।
और क्या कंटिन्यूस ना 1 घंटा पढ़ा के कोई भी बोर हो जाएगा। बस पढ़ाओ, प्रॉब्लम डॉक्टर से करने दो, नहीं कर पाएगा तुम कर लो, कर लेगा तो बहुत अच्छा है। तो हो गया शिवानू, खत्म करो 8 बजे, 5 मिनट पहले छोड़ दो। इतना बोर कर रहे हो हमको, वो भी 2 घंटा पढ़ के क्या करेंगे? क्या करेंगे? भगवान का अच्छा वीडियो ना अपलोड बस इसमें पढ़ नहीं सकता। 1 घंटा 55 मिनट हो गया तो क्या होगा?
कंप्यूटर साइंस एमआईटी की है। इंटरव्यू के लिए कॉल आ जाएगी। आज मैंने वहाँ के एचओडी से बात की, मैंने बोला मैंने मुझे सबमिट कर दी, कह रहे कुछ नहीं मांगते हैं, 10-15 दिन का दे तो वैसे ही बोला सर्टिफिकेट ले रहे हैं, ये कर रहे हैं, वो कर रहे हैं, तभी तक हो जाएगा। हाँ अबे एमएल पढ़ खत्म हो गया क्या? अबे कोई नमकीन नमकीन रखे है क्या? वो तो तुम बताओ, तुम साले, ये तो तुम्हें करना है ना, ये मैं नहीं करूँगा, और ये अपडेट करो पूरा।
ऑरेंज नहीं, नमकीन मेरे घर पे बहुत रखा है, रूम पे। रूम पे so so what is a good order to compute the values of vi using dynamic programming? So vi depends on vj, so accepted answer is from vn to v1, so from last to one basically, so from vn to v1. So vi means like what order you have to follow basically. Okay, so so they are asking about like you will go from right to left or left to right. So how much time will it take to compute v1 using standard dynamic programming? So computing vi requires scanning vi plus 1 to vn, so it takes order of n minus I, hence the overall time is 1 to n minus 1 or order of n square. Okay, so this is the correct answer. Okay, now last question is important. Like suppose we have 30 spaceship whose height are as follows. Okay, 30 spaceship we are given. So what is the maximum number of spaces we can shoot down starting from the first one? Okay. So we know the idea. We know. Okay. Now we have to find out the answer. So what is the so I have shown you that how we can solve it. Okay, how this is solving. Okay, so you have to apply the same technique and solve it. Okay.
मुझे थोड़ा बताओ कंप्यूटर साइंस से रिलेटेड, क्योंकि मेरा वो सीएस में
उसको दे दो ना, सर को दे दो, उनका वीडियो दे दो। वो सर उसका वीडियो देख लो अपना, उसका राबुला का,
मनी करने का
नहीं राबुला का मशीन लर्निंग नहीं, कंप्यूटर साइंस का ओएस बोएस।
करने से नहीं पढ़ने वाला। मैं सिर्फ मशीन लर्निंग पढ़ूंगा बस।
वो कंप्यूटर साइंस थोड़ी है मशीन लर्निंग, कंप्यूटर
मशीन लर्निंग की वैकेंसी है ना।
अबे इंटरव्यू कुछ नहीं होता है, मैक्सिमम तुमको दो टाइप का इंटरव्यू होता है, ठीक है। एक तुम्हारा प्रेजेंटेशन देने के लिए बोलेंगे।
हाँ सर, हाँ सर,
तो हो गया मानो
अरे आप आराम से पढ़ लोगे। अब ऐसा हो जाए, अरे ये मैं पढ़ लूंगा। अरे मैं आपको इसलिए बोल रहा हूँ, काम का है बाबा, मैं आपको इसलिए बोल रहा हूँ, मैं आपको बोल रहा हूँ कि आज तक मैं बोलूँगा मुझे कंट्रोल आती है। मैं बात को सुनो, मैं आपको इसलिए बोल रहा हूँ कि आपको ऑब्जर्वेशन और अच्छे से आता है, इसलिए मैथमेटिक्स ये जो ऊपर आया है मैथमेटिक्स फोकस, कोडिंग फोकस नहीं है। अरे मेरे को देखने दो कहाँ पर है। देखो ये इस नोट से आप हर का नोट को वीडियो में लिखा हुआ है। ये नोट वीडियो कहाँ है? वीडियो भी है, थोड़ा क्लिक करो तो सिर्फ थोड़ा ना प्रॉपर लिखा हुआ है, उसका वीडियो भी देख सकते हो, उसका यूट्यूब में वीडियो है पूरा। अच्छा इसका तो सर भेजे थे आपको अरे मैं बोला बहुत सारा वीडियो रात में ही अभी यहाँ पे ऑप्शन देता है वो उसको देख लेंगे। रात में बस 1 घंटे पढ़ना है। प्रकाश जैसा नहीं करना है, ये देखूंगा। अभी वो बनाया
Okay, so Jay is saying so it is 2:23, so it is basically 9. So maximum number of species we can shoot down starting from the first one. So what it is, so for instance, so if you start so from 71, okay, so 71 you never go to 98, you can go to 68, okay, from 68 you go to 68 you go to 54 or 65, 68 you go to 65, okay, now 65 you go to 63, okay, so from 63 you go to 61, okay, 1 2 3 4 5, this is not possible, okay, so 71 to 68, 68 to So 6. So start from last 6. Okay. From 12. Okay. We can add 44. Fine. So or else we can if we skip 44, then we can go to 70 is very high. 70 34. We can go to 70. If we go, we cannot go to so after 12 we can go to uh, 21, then 28. So then you can go to 48, then 68, then 78. So this sequence we can follow, like 71, 68, 40, 8. Okay. Okay. So 28, 12, 6. Okay, so this sequence we can follow. Fine. So this was all. Okay, 6, 12. Yes. So this what Joy is saying. So this is also fine. So yes, 6, 12, 21, 28, 28, 33, 46, 68, 71. So, so this is the sequence. So thank you everyone for joining the meeting. Okay, we'll meet next week soon. Okay, thank you.
Thanks, Shubham.
Sir, can you explain me this problem once again?
Hello.
Hello, sir.
Tell me.
Sir, can you explain me this problem once again?
Oh wait. So this is a problem of उसको आज ही जानना है सब कुछ. Okay, so you can read it down. Okay, so it is saying that you are playing an old style video game in which you have to shoot down alien. Okay, so you have so this is your TV. Okay, or video game. Okay. Okay, so what is happening that in previous like beforehand you have given the height of the spaceship. Okay, so this is the height of the spaceship. Fine. So this is the height of the spaceship. Okay, so what happened that first at height 20 the spaceship is coming from left to right. Okay, from left it is coming and from right it is going. Now 8 at 8, so if I use blue pen it will be better. The first 20 is done. Now at height one alien is coming. Okay, now then at height one alien is height 12 one alien is coming. Now at height 16 one alien is coming. Fine, you got the point. So one alien is coming from left to right. Okay, now you have a gun. Okay, so you have a gun. Okay, so what is the funda here, that you can start from the top. Okay, so you can start from anywhere. Okay, so you can so if you kill alien at 20, okay, it is fine with your gun. Then you keep down your gun is here now. Okay, your gun is here now, and you shot down alien at height 8. Okay, so then you can't go up, so you can just go down, but you can never go up. Got it? So you have to skip this alien. So you have to skip this alien, and then whenever alien at height 16 will come, then you have to hit it. So this is like the problem is given. So these are the 30 heights. They have given the 30 heights, and you have to find the longest decreasing subsequence. So this is the longest decreasing subsequence. Fine. I think you got the answer. Hello.
Yes, sir.
Yeah, yeah. Okay, okay. Anything else?
Thank, no, sir. Thank
Oh,
you, sir.
okay. Thank you so much. Yeah. Thank you for joining.